I worked on this when I was at Microsoft. GitHub looked at this and said, hey, actually, this can solve one of our problems, because what happened pre-libgit2 adding merge was that when you went to merge a pull request, GitHub would shuffle a bunch of bytes on disk for it would do a checkout of your repository on disk in a temp folder, and then run the merge because it had to, and then figure out what happened on disk. And it's like, what? And so moving to libgit2, all of a sudden they just ran the merge, didn't have to update any files on disk, just like had the results in memory or in a tree in the actual, like, in an object. I didn't realize this when I was working on it, and of course GitHub was like, "Oh, cool! We just like massively improved the speed of our of the way we handle pull requests." And I was like, "Oh, cool!" Like, it just accidental benefit.
Ed, thank you very much for taking the time to go on this episode with me. As usual, I want to start and dive right in. You are the author and maintainer of libgit2. What is libgit2, and how did you get involved in SCM tools to begin with?
Yeah, that's a great question. So I am the maintainer, and author is a little, I didn't start the project. Okay. So I don't want to take credit for that. What is libgit2? Well, libgit2 was actually started by a guy named Sean Pierce. Sean was one of the contributors to Git itself. The Git command line application that you run. And he wanted to be able to take Git and put it in another application. I actually think what he really wanted to do was be able to call Git from Java, although I don't know. One of the really unfortunate things about this is that Sean was like a super prolific developer and like engineering manager as well. Passed away a few years ago. So like he worked on Git. He started the libgit2 project. Then he went and started the JGit project. So like really, a quiet luminary of version control software engineering.
That's a big loss to the community for sure. Yeah,
100%. And just like by all accounts, an incredible person, like a great human. So often you see people who are great engineers who are missing like that human aspect, and Sean was not amongst them from by all accounts. Again, I never had the fortune of meeting him, but yeah. So Sean started the project, and I mentioned, I think he wanted to call it from Java because he left libgit2 and went and worked on JGit. And so like JGit is used at least internally at Google to run their version control systems, like the back end, I think, for and somebody I hope can correct me because I've never been a Googler, for sort of their version control server, what handles Android ultimately. But like so he kind of started libgit2 and then left it, and then the community took over. And in fact, who took over was GitHub. So Scott Chacon, one of the founders of GitHub, came in and started working on libgit2. Vicent Martí, who was a super early engineer at GitHub, started working on it. And the rationale there is that GitHub uses a mix of Git and libgit2 to serve your repositories. Like when you run git clone, it talks to a Git daemon on the back end. But when you like actually navigate on github.com, the UI, you'll talk to some mix of Git and libgit2, depending on a number of factors.
So let's clarify this a little bit. Like, what is the demarcation line? What's the delineation line?
That's a great question.
Yeah.
So when you run Git on the command line, you're talking to Git. But if you want to, if you're, say, writing some Ruby and you want to talk to a Git repository, you have two options. Well, you have more than two options, but like, let's focus on two options. One, you can run the Git command line just like you would as a user. The problem is you're running the Git command line just like you would as a user, and you've got to figure out what it's telling you. It doesn't emit JSON. It doesn't emit XML. It doesn't emit, maybe it'll emit, depending on the command, some fairly regular format that's relatively easy to parse as a computer, but you often end up just kind of screen scraping the output. And that's not super ideal. Enter libgit2. It's a C library with APIs that are designed for you to call it from your application. And so let's say you want to clone a Git repository, you can do that, but you can also just like get really focused on, you know, whatever minutia you want to be able to render to your users. Like if you want to run history, that's really cool. We'll just give you back proper objects that you can put on screen or keep parsing in some other way. And it's written in C, which is sort of not ideal for many applications. Like who's writing a web app in C? The nice thing about C though is that it is sort of the common denominator, if you will, for working with. You know, you can FFI, and I hope that you don't have to, but you can call C from Ruby, you can call C from Rust, you can call C from Python, you can call C from absolutely every language, because that's every language can, you know, FFI, which means, if you're not familiar with that term, foreign function interface, I think. But ultimately the ability to call C from your language. In .NET, it's, I'm blanking on it. P-invoke. You can P-invoke from .NET. You can call it from Ruby. And so like that's really the value prop for libgit2, is it's the basis by C library, other Git libraries build on top of. So you've got rugged, libgit2 sharp, etc., depending on your language.
Fantastic. So just to dive a little bit deeper into this, we talked about like what's the integration mechanism or the interface, right? But what is libgit2 in terms of, is it a wrapper of Git, or does it re-implement some of the functionality of Git, or does it call Git in the background as a sub-process, or how does it really work on that end?
Yeah, it does not call, like, I don't want to screen scrape Git. And like, so we don't, you know, the goal of libgit2 is not to prevent you from having to screen scrape Git, and I do it myself. It's actually a re-implementation. And so like early days, like going back to, again, what I think was Sean Pierce's goal was, he looked at Git and it was not able to be used from another application. It was a command line interface. And he looked at this and said, well, if we're going to build a library to do Git, to work with Git, let's re-implement it, and then let's build a CLI on top of it, I think. And the reason I think this is because of its name. libgit2, there was no libgit1 as a standalone product. The only libgit is the static Git library that Git itself builds. When you compile it, it will emit a libgit and then link a bunch of its applications to that. And so my belief, and again, I wasn't around for this, my belief is that the genesis of libgit2 was to be the shared library that you could call from another application, but also Git itself built on top of. So it is a re-implementation. So it you know, when you run Git, the moral equivalent of git log with libgit2, it will actually like go open your .git folder, start looking around, poke around at objects, start reading them in, you know, branches, stuff like that, and try to make sense of that world. So it's challenging to do that, to be a re-implementation of Git. When you start poking at Git, and I think you might know this, when you start poking at Git, you're like, this is really elegant and easy. Like object files like make a lot of sense, references make a lot of sense. And then you keep poking at it and you're like, well, actually there's these weird corner cases when you've got a ref log and you need to rename a branch, because everything's like sort of lined up in path space. You can't have you know, you need to do something special with ref logs when you change a branch, you know, from a folder to a file, et cetera, et cetera. 100%. So there's actually a lot of like really complicated edge cases that you don't expect.
That's exactly it. Like I've started a series where I'm re-implementing Git from scratch in Go. And on the surface, it looks like, oh, this is a fun project. But then you start diving into it and you're like, oh, this is really elegant. Like how the objects are structured, how the blobs are structured, the commits, so on and so forth. And everything sort of creates this framework for you to work efficiently, you know, with all of these items and objects. But then, as you mentioned, the edge cases start hitting you and slapping you in the face from here and there, and you need to tackle this one and this one. And then when you need to make changes across a lot of different stuff, then things become way more complicated. Yeah. And yes, I totally understand this. So you mentioned that libgit is a re-implementation of Git of sorts, and I think this is a very good design choice, to be honest. Just because, like, I think it's great to have like a core library, and then you can build CLI tools around it. You can build APIs on top of it. It's a pretty good model. But Git is now more of a toolbox rather than just a single tool. So how does libgit keep up with all of the new features, that are coming in?
Poorly. When I got involved with the project, we had a handful of people who were working on it more or less as their day job, including me. Like, I was at Microsoft at the time. We wanted to bring Git into our tools. So I was working on Visual Studio and what is now called Azure DevOps. We wanted to add a Git client to Visual Studio. We wanted to add a Git server to Azure DevOps. And what we thought about bringing Git in itself, and trying to figure out that. But like at the time, Git on Windows, which is where Visual Studio runs, was not amazing. And Git, and as a server, so on Azure DevOps, it was even less amazing. It's Git for Windows has had a ton of investment since then, so it's much more mature than it was at the time. But we were like, well, I actually think that libgit2 is the answer for us here. And so, like, I was working on it full time. There were a number of GitHub engineers that were working on it full time, and so like the velocity was huge then. It was also very libgit2 itself was very immature then. So like we've sort of reached a level of maturity where most of the things work. There are things that are missing. For example, we don't have support for Git LFS in the box. I guess neither does Git itself. I would like to see that. We don't have support for some of the newer features that Git is putting out. Like we do have. Sorry, I'm going to get like super low level for a second. We do have multi-pack indices, which is a nice performance improvement. But we don't have some of the like narrow clone support, and we should. Like that's something that I want to have. But like I'm sort of the primary, person writing code for it these days, and so like I'm going to work on I'm going to scratch my own itch, if you will. Like what I'm working on right now is like not a new feature at all to keep up with Git. It's that our clones are really slow. And so like I've been working on making that faster. I think that's an important thing to do. But I also only have so many hours in the day. I've got a day job that doesn't have anything to do with libgit2 at all. So this is just like really a hobby project for me. So we're not keeping up with Git. Now, so the question is that okay? I think that the answer is yes. I would love to do more with like the new functionality that Git's doing. But at the same time, a ton of people are using libgit2 and are reasonably happy with it. I'm seeing new tools built on top of it every day. There's a new tool called Git Butler that I'm super pumped about, from Scott Chacon and a couple of other people. Scott, once again, one of the founders of GitHub. Super excited to see what he's doing. I think it's going to be incredible. It's like by invitation only at the moment. I'm super excited about the beta. So like in some sense, I'm not too unhappy with our velocity. But like I said, it's a tough balance to know what to do.
On the first episode of this season, I was talking to Simon Willison, and he was the co-creator of Django. He created Dataset, and we were talking about open source models and how difficult it is to maintain some popular projects. So if I am to ask you the same question, what do you need so that the community can keep on thriving and that the libgit2 keeps on being maintained? Because I understand the pressure of being an open source maintainer. I work on a number of open source projects. Like at GitHub, we have a lot of open source actions, for example. And it's very difficult for us to maintain them because we have our day jobs, but at the same time, we have to maintain these. The community is very active. They want new features. They want to support certain edge cases, and it's extremely difficult. So my question to you is, what do you need to be successful?
I would love, I think that we were at our best, the libgit2 project itself, when it was something that I'm going to pick a person. I need Carlos Martin Nieto. That's who I need. Or Vicent Martí. Like these are a couple people that were core contributors to libgit2 back in the day, and their presence was incredible. Like the ability to pair with them was great. Both of them thought about problems completely differently than I did, which was amazing. Because I would look at a problem and say like, wow, that's going to be hard. And they would go and solve it. Similarly, they would look at a problem, and I hope this happened. I don't know for sure. And they would say, wow, that's hard. And I would go and solve it. I think that they bring a lot of different talents to the table. So I would say what I really need is a partner in crime who thinks about things completely differently to me, that is going to challenge me and tell me I'm wrong. I picked those two out. We've also had Patrick Steinhardt on the project, who also thinks about, like, really challenged me in a lot of ways. And the project was better for each of their contributions. And so like, that's what I need. And that's not what, and it's funny that you bring up actions, because I also worked on the actions team for a little while. And the challenges are really different. Like I get to say, this is my hobby project, and I can get away with that. When somebody looks at GitHub Actions, you have the same problem, which is that like this is a percentage of what you focus on, and the community's like, they don't get it, right? They're like, why doesn't GitHub put like one engineer or something on all of these actions? Except that doesn't, like, now that I've been on both sides of it, that doesn't scale, because like the needs for each action, like some days every action needs a lot of work, and some days no action needs a lot of work. And so like it's really super hard to plan. I'm actually really sympathetic to that problem more than I am my own. Like I just get to say, hey, it's busy at work, it's busy at home, nothing's going on libgit2. Sorry, y'all. And nobody really minds. I think some people probably mind a little, but nobody really minds.
100%. Like the problem on our end is more of expectations, maybe, as you mentioned.
Yep, exactly.
And it's also a difficult prioritization problem. How do you strategically prioritize the work on these? And they're important. We did publish them, and at the end of the day, we're responsible for maintaining them. But yeah, it becomes a tricky problem. You mentioned like a few superhero level engineers, or I don't know about terminology. A lot of, like, some people don't really like 10x engineers and all of that stuff, but I think there are 10x engineers within certain contexts. What do you think made these folks you mentioned, super good at what they do, in your opinion?
I don't know.
What's their magic?
I don't know. Like Vicent is magical. He's one of those people that's just able to jump in and solve any problem that is in front of them. And I don't know where that came from.
How long have they been in the industry? That quite
not like so when Vicent was working on libgit2, he came in as a Google Summer of Code intern.
Okay.
For GitHub, working on libgit2. He was a university student.
Wow.
Like a disaffected undergrad in computer science who just wanted to write video games. Instead, like, came in and worked on libgit2, and then worked on a bunch of other stuff at GitHub. I don't know how. Carlos Nieto, I also mentioned. Carlos Martin also came in as a Google Summer of Code intern to GitHub and libgit2. So maybe there's something there. I don't really know, like, what it is about them, but there are definitely some engineers that I've worked with that are just incredible. And actually, libgit2 had a bunch. Russell Belfer was on the project, also an amazing engineer. Something about we got really lucky on libgit2, and I'm still like cashing those checks, right? Like I'm they built it, and now I get to say like, oh, I'm the maintainer of this thing that like that all these amazing people worked on.
Awesome. I definitely relate to this. I see a lot of great new talent come in, and you get surprised by their capabilities, and what they can do. And I think this type of project attracts a certain type of talent. I think also, not everybody gets not only the ambition to work on something like this, but also the curiosity to work on it, and the how do you call it, the confidence to come in and contribute and add value, right? And I think for you to be able to do that, you need to have a certain set of skills that you've honed over a certain period of time. And nowadays, I'm not really surprised by new talent. Like maybe in our time, accessibility to machines and computers and things like that was much more difficult. But nowadays, like every 5-year-old has an iPad in their hands that they're learning how to code and all of that stuff, right? Which definitely gives them like a very big advantage to maybe us when we started our careers.
Yeah, I think you might be right. I was very fortunate. Like I got a Commodore 64. Like Commodore 64s went on like fire sale at one point, right? Like, and I was the beneficiary of that. Like, I got one as a kid, and I would go to the library and get like Compute magazine, and I would type in the assembly, and it would of course never run. But like, I learned so much from that, and I knew a couple of other people who had computers growing up as kids, but it was a rarity, and now I agree that the democratization of this technology is incredible. Not only do you have an iPad or perhaps some tablet, like this stuff is at a much lower price point. It's much more accessible, but also like cloud infrastructure. You can just like go create I'm going to shameless plug. You can just go create a Vercel account and start deploying your website. You can run code. You can write JavaScript and run it like everywhere in the world, and you don't have to pay like until unless your site catches fire in popularity. And yeah, that's incredible to me. 100%. I was super fortunate, but like I think the democratization is going to do amazing things for us.
Definitely. And the educational tools, like the amount of free content, the courses, YouTube alone, like it's maddening. And I always tell the future generation, you have no excuse if you're trying to break into this field. Like, and I might sound like the old guy, screaming at the younger ones, but they're really fortunate in my opinion. Like back in the day, I had to go to a coffee shop with like 10 floppy disks and spend a couple of hours renting internet to learn a little bit of HTML,
Oh my goodness.
Yeah, it's much more difficult. All right, let's switch gears a little bit. Have you had the chance to play with Meta's SCM, Sapling, by any chance?
I haven't played with it in earnest. So I've spent a lot of time talking to their engineers. I've played around with it a little bit, actually when it was called Mononoke, prior to its renaming and open sourceization, reopen sources. I don't know how to say that. I think that it's really cool. I think that Google has done something similar in Piper, I think it's called, which like there's some level at which a company gets to where they're like, well, we've outgrown X, where X is perforce git, mercurial, whatever. We're going to go write our own. And it's disappointing to me that none of these have really caught fire, in part because like they didn't really care about the open sourceization of them, which I think makes sense, right? Like you're not, your goal as an internal engineering team who is working on your internal version control system is to make your internal customers happy. It's not to go like build something that's super
put it out there. It becomes much more difficult to maintain and I can understand. There's really no motivation unless there's like a big advantage that comes from putting it out there.
That's right. And so like Facebook, Meta did put it out there. And I think that's great. But it doesn't seem to have like really caught fire. I say that not knowing. Maybe some like huge enterprise companies have started like using it, but I, I'm not using it on a day-to-day basis. You're not using it on a day-to-day basis.
No, I'm just
And so
curious
it
about
hasn't.
it. Yeah.
Yeah, exactly. And so it hasn't caught fire like in the developer mindset like broadly. Um, I think Microsoft came the closest to this because they not only do they have internal engineering needs for the Windows team, for the Office team, for the whatever Bing team, who have huge code bases that don't really fit in a traditional. It's not like you can just git push it up to some Git daemon and have it work. It's not going to work at all. Way too big for that. Like when Linus created Git, he was like, oh, it's made for big repositories like the Linux kernel, which is big,
but it's not Microsoft Office. Yeah, big.
Yeah, it's not Microsoft Office. And you can argue whether like that's a good thing to have a repo that big or a bad thing to have a repo that big, but the repo is that big, and that's ultimately the fact. And so like your version control system needs to deal with that. And so Microsoft also is trying to sell you version control tools. And so like I think that they went in, and I'm super biased here because I was part of this team, but they went in with the most clear direction of we need this to support our internal engineering tools, and we would like to make this available to the world. And still that didn't really catch fire in terms of VFS or Git or Scalar as it's now known. But what I do think that Microsoft is doing well is like pushing these, some of these changes back to make Git scale more. So you've got things like narrow clone. These aren't just like Microsoft only innovations, but like, multi-pack indices, stuff like that. Some of them were pushed by Microsoft and or GitHub engineers. Some of them were like collaborated on, but like, I like that vision. But still like, this isn't things that people are using on a daily basis. Like why maybe if I ran git clone, maybe I should get, it should be super fast even on the Linux kernel or even on like something smaller like the libgit2 repository, the Git repository.
Because from my experience, I see different levels of understanding of the tool. So there are the folks who will never hit these boundaries of scale. A lot of the startups, just use Git. I know a lot of teams that have never even thought about work trees or sparse checkouts or anything of that sort, right? Because they never ever needed them. Their work is just, clone, add, stage, push, rebase, this sort of stuff, and they never hit these problems. And the biggest problem they have maybe is mistakenly pushing some binaries or stuff like that. But the bigger enterprises, they definitely have that problem. And when I worked as part of the services team at GitHub, this was definitely a daily conversation we were having with different enterprises. And optimizing Git repositories is definitely a big deal. Rewriting history was also a big part of this optimization effort. But I personally think, and this is my personal opinion, that something is missing, and we definitely need one more thing to come. Like the next evolution of Git is now very necessary, at least to tackle this scale. And I'm not sure how that looks like, to be honest.
I mean, I have opinions, but I agree with you 100%. Like, why are we having these conversations, in 2023 about optimizing your Git repository? Like, I think your example was great. Like, oh, they had a problem because they pushed a binary. Like, why is this a problem? Like, why do we have Git LFS separate from Git? Like, is there no way to put an ISO image in a Git repository and have that make sense in 2023? Like, why can't everything just handle this for me? And I think that's sort of like what I would like to see as the next evolution, not binary specifically, but like why when I do a clone, like, so for something that's like a hobby project, like a Hello World, fine, give me all of history. But like, if I just start running git clone on the Linux kernel, why don't I just get a shallow clone by default that like will fill itself in if I start, like if I want to check out another branch, like, okay, most people are connected all the time. When I started out in building version control tools, it was a long, long time ago, we talked about the developer on the airplane experience because, airplanes didn't have internet back then. So I'm really dating myself, I know. I guess talking about building version controls tools that weren't Git really dates myself as well. But like that was that was like mind blowing to us. Like we want to build like version control tools that could work offline, and now we take it for granted that they only work offline. Like there's probably a middle ground. I think we've really overcorrected into distributed version control tools to where we think that they couldn't possibly work without, or require an internet connection to work. And I think that like we can recalibrate on the middle ground a little bit more. I actually think that would be what I would like to see,
because times have changed, and they change so fast that these tools, it's very difficult for them to keep up, especially also because they're not commercialized in a way that there's like a big enterprise behind them that's driving their evolution in a way, and it's very tricky. And I can understand one of the value proposition for Git was literally for it to be 100% distributable and for it to be fully workable from a local copy, and that was what made it great. But I think right now with the speed of all of the internet that we have, the connectivity that we have, that is not as big of a deal as it was before. I mean, it doesn't need to become the default, and it could be like a feature that is enabled on a need basis. While you're correct, we need to optimize a little bit on the other end of the spectrum. Great. What are some of the most memorable technical challenges you worked on solving? Whether in libgit or any of the other work that you've done before. Is there anything that comes to mind that was very, very interesting?
I think that the most interesting thing I worked on in libgit2 was doing merge. And actually, in some sense, I approached it like, oh, okay, we're just going to go add merge functionality into libgit2. It's core to a version control system. It doesn't matter if you can branch, if you can't get that code back. Like, what's the point of branching if you're not going to merge it back? And it was something that libgit2 lacked when I started looking at the project, something that we knew we needed. I'd worked on a bunch of version control tools before, so I wasn't like, oh, this is going to be hard. There were tricky elements to it, but like what was really cool to me was how well how well it worked. And I don't mean that from a technical sense, actually. And so I guess I'm not answering your question, but like I set out to just like go add merge and have an API for it. And one of the nice thing, I guess this is what was elegant about it, was that libgit2 as an API, as a thing that like just needs to go do some work. Like the way I approached merge was like, well, I've got a tree, whether that, a branch, it points to a commit, points to a tree, et cetera, et cetera. I've got a tree, I've got another tree, they've got a common ancestor tree, and I need to go do that work and emit a new tree. Actually, we put it into the index when we do a merge, but that's a little bit beside the point. And so like that was just how I approached the problem. Feels relatively straightforward as I say it. That's not the way Git approached the problem, at least not originally. When you do a merge in Git, or that's not true today, like they've actually reworked the merge engine in Git, thankfully. But it would just like splat a bunch of files on disk. And that's cool, I guess. But like that's not the level of abstraction I think in. Like I want to produce a data structure. I don't just want to like splat into the working directory the results of the merge and what happens when you have a conflict. Well, you update the index, but in a weird way, yada, yada. The takeaway, though, was that like I worked on this when I was at Microsoft. GitHub looked at this and said, hey, actually, this can solve one of our problems, because what happened pre-libgit2 adding merge was that when you went to merge a pull request, GitHub would shuffle a bunch of bytes on disk for it would do a checkout. of your repository on disk in a temp folder, and then run the merge because it had to, and then figure out what happened on disk. And it's like, what? Um, and so moving to libgit2, all of a sudden they just ran the merge, didn't have to update any files on disk, just like had the results in memory or in a tree in the actual, like, in an object. I didn't realize this when I was working on it, and of course GitHub was like, "Oh, cool! We just like massively improved the speed of
Of
our
course.
of the way we handle pull requests." And I was like, "Oh, cool!" Like
Definitely.
it just
Like
accidental benefit.
people
And so
don't
that was really
know
cool.
people don't know the magic behind clicking on that merge pull request button. That's probably the most complicated button, in the entirety of GitHub. Nowadays there are a lot of complications, but like that for the longest time probably was the most complicated thing.
Yeah, especially then when it's like, oh, we have to check out on disk and then update it. It's like, whoa,
Wow.
that was a little gnarly. So I was like super proud of that, like accidentally. When
Definitely.
I found out that, and so for a long time, and I'm not sure that this is true anymore. I think that at least GitHub has moved over to the new Git merge engine, which is merge dash or merge or. It's got a funny name because I think maybe there's more to it, but the way you specify a merge engine in Git is that dash S. So you would run git merge dash sort, ORT. I think. Clever name. Anyway, so I think GitHub has moved over to that now. But like for a long time, every time you opened a pull request on Bitbucket, GitLab, GitHub, SourceHut, any hosting provider, it was ultimately running libgit2 to do the merge, which I was like, I was really proud of. Like this little, like I added it so that we could put it in Visual Studio and Azure DevOps. Like it powered everybody's pull requests, or merge requests, if you call it that. So I was super super duper proud of that. But like actually, that wasn't like a super hard technical challenge. Like three-way merge is a well understood problem. The hard part of merging is understanding where your base is, and Git makes that pretty easy, actually. Like in previous version control tools that weren't based on a DAG, it was always hard to figure out, like, if I have a branch A and a branch B, where did they come from? Like what you would record that somewhere, and then when you did a merge, you would record that. And so like figuring out bases was super hard. This was like the reason that branching and merging was like sort of flaky. Flaky is not the right word. It implies that it was buggy, perhaps, but it was like super complicated in a version control system like Team Foundation version control, because like it was gnarly. And then people would do a baseless merge, which throws out the common ancestor entirely and is never what you want. But like it would get around some of these problems, and you'd get gnarly conflicts instead. So like anyway, but the actual three-way merge functionality is just really well solved. And so like this wasn't like a technical challenge. Definitely the hardest technical challenge I think that I've ever dealt with was around the NTLM authentication protocol, which was not a well-published spec, and we had to reverse engineer it a bit. Some people had already done some reverse engineering, especially the Samba team, but like we had to. When I was at Team Prize before, we were working on a system that talked to Microsoft, again, Azure DevOps. It was called Team Foundation Server at the time, but we needed to support NTLM too, and we couldn't. So like we had to go make that work. That was definitely the one of the tougher technical challenges I've been a part of.
Ed, this has been very, very insightful. Let's switch gears a little bit and talk a little bit more about your career. You were at GitHub prior to the acquisition, if I recall. And I remember also you maybe left 1 or 2 years after I joined. What was GitHub like at that point in time?
GitHub was an early startup at that. When I started, it was, we were big enough that we thought that we had it all figured out, but we were small enough that we didn't. And so and it was a bunch of really, really, really smart people, which is great a lot of the time. And some of the time, when you just need to go get something done, you're frustrated by the intelligence. and which sounds weird, but what I mean by that is like every problem, and not just technical problems, even business problems, we would always look at it and go like, well, let's boil it down to first principles. And it's like, no. Enterprise sales has okay, that's a bad example. I actually thought the enterprise sales team at GitHub back then was great, but like, I'm just picking an example. Like enterprise sales is well defined. You don't go reinvent enterprise sales. You find you hire some people that are
Done it
experts in
before.
this, and you just let them go.
Exactly.
Right? Like there's a rhythm to this. And GitHub was like was too smart for its own good sometimes, and we would just like reinvent processes that every other company had already figured out, and we would do it poorly. And ultimately, we would snap to some process that some other company had figured out, and it would be more successful. So it was a little bit, it was challenging sometimes. Like certainly, like writing code was great. I worked with some like incredible engineers, and so that was like super duper fun. But like, and I would have loved to have stuck around in a sense. Like the reason I left was because I didn't realize I realized I was no longer a software engineer. I had come up from a small company. I was like engineer number 3 or 4 at this version control software company that got bought by Microsoft, and Microsoft let us keep running like we had been in a sense. Not really. They definitely brought in a lot of their overhead, and I was like, oh, this is stifling me. This is terrible. But what I hadn't realized was like, as a software engineer, my title was senior SDE at Microsoft. I was still talking to customers like all the time, and that had been true at this little company that had gotten acquired, Team Prize, because we were small. Like I talked to customers pre-sales, I talked to customers post-sales, I talked to customers all the time. And Microsoft let me keep doing that. Like one of the first things that I did after the acquisition was like I did a tour of the Midwestern America, talking to customers. Going in, sitting down for a day or two in a city and talking to people, and then moving on. That's a thing a PM does at Microsoft most of the time, and that hadn't really clicked to me. I'm like, I don't really understand the difference between product and engineering. I was an idiot. Maybe I still don't actually understand, but that's neither here nor there. And then so I was like, cool. I'd been working on this Git stuff, and we put Git in Visual Studio and in Azure DevOps, and doing that. I was working on libgit2. I was talking to a bunch of people at GitHub. Like I really enjoyed hanging out with them and talking to them and blah blah blah. And so eventually I left and became a software engineer at GitHub, and I absolutely hated it because I was expected to just sit down and write code. That's not 100% true, but like it was true enough that I was like, wow, this is not cool for me. I don't enjoy this anymore. So I left, and I moved into a product role, and I think that's a much better fit for me. I like talking to people. I like
love it,
being on the product side.
Great. So you opened the door for me for my next question, and because you fall at the intersection of software engineer and product manager, right? And also like your current role is a product manager. Mm-hmm. Do you think your background in software engineering gives you an advantage as a product manager, or do you think it hampers you from being able to have another perspective that is not necessarily ingrained in technical depth, if you know what I mean?
Yes. I think it does both those things. It's hard for me to imagine doing product management anywhere besides a DevTools company. I think that my software engineering background is, in some sense, my secret weapon for product. I've interviewed at other companies. I started talking to some financial services company, for example, and I got like halfway through the conversation, and I'm just like, I use your tools every day. You power checkout for all the websites on the planet. And yet, like, I'm not excited about this. I'm still excited about dev tools because I'm still a I think of myself as a software engineer at heart, even though my title is, whatever product
That
management.
never goes away. Yeah.
Yeah, I don't think so either. And so, like, I'm pumped to, next. So right now I work at a company called Vercel. We have a JavaScript framework called Next.js. We just had a pretty new release. It like sort of upended the way that we handle like routing and architecture. And I rewrote my personal website in it because, like, of course I'm going to. Like, what else would I do? And it was great. It was a great learning experience. And I would never do that if I would never go build an e-commerce site for fun if I ran product at some financial services checkout shopping cart company. That sounds terrible to me. So yeah, I think that it's necessary both in terms of my ability to get excited about the products that we build, and it certainly helps me. Like, I've known product managers who don't need to understand the tech at a really deep level, but I can't not. I like, if I'm going to go, if you're asking me like, hey, Ed, as a product manager, what do you think we should prioritize? Should we add HTTP3 support to our to our proxy, or should we? I don't know what, like,
whatever. You have to understand it. Yeah.
Yeah, and I'm like, well, like, I understand HTTP3 enough to be able to talk about prioritization at least.
Correct.
And so,
as I always say, like, if you don't have the knowledge or the information, someone else is driving the agenda. Be it your software engineering team who have their own, because the selection of information, no matter how inquisitive you are, no matter how good of an investigator you are, right? There are always going to be information gaps that are going to be either hidden from you intentionally or unintentionally, and they're going to cause you to have an uninformed decision, or maybe a decision that doesn't necessarily is not the perfect decision. And that's why, for example, like, as you mentioned, like, I work with Chris Patterson a lot, or we've worked like recently. I love Chris. Because, like, whenever we come to a technical like stalemate, or like where we need to make a decision, right, to go in a certain direction or not, Chris comes in and he's like, no, we do this because technically X, and it's perfect because we don't really need to have consultations to carry over context and sort of try to transfer as much technical information as possible in a non-technical way. Chris just understands it. He's in the industry. He knows it. We move on. Perfect. And that, I think that's a big advantage for product managers to understand at least the area that they're working in at a very deep technical level. And what I love about Chris, for example, is like he literally created a pull request for a feature just so that he can understand a certain area of the product a little bit better, right? Like,
it's funny that you mentioned Chris, because I was actually about to. Chris was in many ways the product manager that I looked to for inspiration when I moved from engineering and into product. Like, I guess he was my mentor without him actually knowing it. But one of the goes back. I was going to mention this because it goes back to your question about, like, is software engineering background a help or a hindrance in product management? And it can definitely be a hindrance as well. Like, when I moved into product, Chris Patterson, it may have been less charitable than this. But, like, what I remember from the conversation was him saying, you're going to be fine as a product manager. What you need to be sure that you don't do is do engineering, because that's going to be how you fail as a product manager. And I thought about that, and I'm like, cool, no problem. And I'm like, I will just not write any code. And that's what he meant. And it took me a while to realize what he actually meant, because, like, I think very early, I was like, here's a spec. And, like, it was a technical spec. It was like, here's how we're going to implement all this stuff. And I was like, here's a spec. And, some engineer looked at this and they were like, what is this? And I learned very early that my job was not to be like the person who solves the technical problems anymore. My role was to solve the the business problems, the customer problems, and to shut up and let them do the engineering. And I think that that's an easy failure mode for technical product managers early in career or early in that in role. I worked with one, relatively recently within, I won't name names, like super smart, totally understood the problem domain. Like it would we'd have a conversation and they'd be like, well, in a year we need to be here, and like just lay it out for me. And I'm like, that's absolutely right. That's about right. Like maybe it'll take us, an extra 3 months to get there. Maybe a year is being really super optimistic. Maybe it'll even take longer than that. But like totally understood, had the vision, and then would go and say, well, and so here's the way we're going to engineer it. And I'm like, you need to stop there. And like, yeah, the engineers were like, no, you have crossed the line. And it's tough when you're technical and you know how you want to go build it to stop and not go build it.
No, you have to trust that the other end are masters of their craft just as much as you in many ways. Right. And I always like to summarize it. And I've had like lengthy videos to talk about this because I also see myself as a multidisciplinary, a professional. There's the how, there's the why, there's the what, right? And the product manager can define or should be defining the what and the why. The how is left for the engineers. And that doesn't mean that everybody should stick to their lane. I'm pretty sure that people can have opinions and crisscross, right? But then the final say is left within these boundaries to the teams that own these areas. And that doesn't mean that healthy conversations cannot be had. That doesn't mean that arguments or debates cannot be had. But there are areas of ownership that are clearly defined.
So too. Definitely. And, one of the things I love about, right now we're about 400, 25, 400-ish people. Startup is like, so many of the engineers have an idea of the product and like what they want to go build. And that's the other thing. Like I said, like I want to be in dev tools. I also want to work with engineers who just like do the job for me. Like they're all like super, super thoughtful, about the product side, which is good and bad, like because that's a lot of the fun part. And so like often I get stuck with the real true PM bits, like thinking about the release and working with go-to-market and pricing and packaging and but we still are able to collaborate on the what I think of as the fun bits is the ideating on the product itself.
Brilliant. All right. So let's talk about Vercel, right? Where you work right now. So I personally, I dabble with front end. I've built websites before for the longest time in my career. So help me understand the value proposition because I've never used personally Vercel myself. What's the added value of this entire company and the product line that you have?
Yeah, that's a great question, and it's one that has taken me a little while to internalize myself because I actually come from back end. I also only dabble in front end, really. Like I came up in network engineering and did some sysadmin on Unix machines like way back in the day. Did some BGP, and so like the idea of like, and I worked on websites as well, but like. My heart is in like the bits on the wire. And so I came to Vercel to really focus on like our storage, our compute platform, our network, and now our storage products. So like I think of myself still fairly back end. And so it took me a bit to get this, but like what is really cool about Vercel is that we work on what's called framework defined infrastructure. And like I think of myself again as like an old school like back end guy, and so I think about like maybe I need to build a Kubernetes cluster, maybe I need to provision this resource. Like let's throw that out because despite the fact that I've done that and I'm familiar with it and I feel comfortable with it, it actually kind of sucks. And like imagine a world where you can run your site and it can scale and you don't have to think about that nonsense. Like that's really what Vercel is doing. like some really amazing developer experience tools that allow you to grow up. So like, let's say you take your framework, your let's say it's Next.js, which Vercel builds, Vercel invented and builds. It's the most popular React framework. And you just like go, you don't have to think about its deployment. You just go build your app. And when you push up your Git repository, or, I guess you can do it from the command line too, but like, just like open a pull request, click that, merge button that is so gnarly on GitHub. And what Vercel will do is like, oh, cool, you've updated your main branch. Let me do a deployment of that for you. And it will handle all the gnarly bits. Oh, okay, so you wrote some JavaScript that wants to run on the server. Cool. I'll provision a serverless function for you. Or I'll provision some running at the edge JavaScript. We'll put it in 18 regions across the world. It'll be as close to your user as possible. Great. And we'll handle all that deployment for you. Like we've got people running Kubernetes clusters. We've got people, thinking about our interconnectivity between, data centers. You just run git push. So that's really the value prop of Vercel is you focus on your stuff and we'll focus on deploying it
amazing
as easily as possible.
So who is it for? Because obviously with anything cloud, and it seems to me like a PaaS proposition, right? Like a platform as a service, like the Heroku maybe of JavaScript in a way. I'm not sure, but like, who is the target audience, and where do you fall on the control spectrum? So, and what worries me, for example, as a developer, right? I deploy my app. I don't really know what's going on. It's automatically scales. Fantastic, great. But someone DDoSes me. Someone tries to abuse my platform. How can I mitigate against getting a hefty bill that I don't know how to deal with, like at the end of the month, for example?
Yeah, for sure. And that's what you're saying is super important. And so that's definitely one of the things that is like top of mind for us. We call it a denial of wallet attack, right? Like a DOS attack is one thing, but like it will also can incur additional spend, and that's super frustrating. So we're very thoughtful about denial of service attacks in terms of like protecting the platform, protecting your site, keeping it online. We have we have the Vercel firewall, which will detect denial of service attacks and just shut them down, mitigate, and that's great. But like actually, it's the accidental problems that lead to that then lead to uncontrolled spend, or can. We can shut down all the network activity leading to a DOS attack, but like if you just like put a while loop accidentally in your serverless function, deploy it, that can get very expensive. So we're working on a number of pieces to help mitigate that. Those sorts of like accidental spends. And we also give you a couple of choices as well. So we have, what we think of as traditional serverless functions. They run in a single region on some hardware that's, you run inside a container. It's pretty standard, pretty traditional. We don't make you think about the containery bits and how it's deployed. But ultimately, it's like a Lambda, it's like an Azure function, those sorts of things. And the way that those things are charged, like if you want to think about the billing, is for how long they've been executing. We think, you take the size of the container and you multiply it by the time it's running, and that's how the bill comes out. And that's cool for a lot of applications. It's super not cool for many others. Let's say you want to talk to a database, or more, a contemporary look is talking to an AI backend. Let's say you want to talk to Chat GPT. That thing does not respond quickly. It takes its time, streams your data back, and so if you're paying for every second or millisecond or whatever that you're executing that function that's talking to Chat GPT, that gets very expensive very quickly. The nice thing about the Vercel platform is we have an option for you, and that's edge functions. And those, instead of running in a traditional container, those run in a V8 isolate. And actually, the cost model is very different. They only are billed for the CPU time that they're using. So you can just like sit there and idle. You can sleep. Put a 2-minute sleep in there, and you're only paying for the actual startup and shutdown. Like while it's sleeping, you're not paying. That means that while it's talking to a database or talking to Chat GPT, you're not paying. So we're actually really flexible in the way that you sort of think about your computing and what you're doing, and you can sort of tailor your costs in a sense to that. Now, in some sense, this violates what I was saying, where like you don't have to think about your ultimate infrastructure. This is like one place where you do have to think about your infrastructure. So like absolute work to be done here on our side, like the developer experience, we need to tighten that up so that like maybe you don't have to think about it at all. But today, like we do have some knobs you can turn to avoid that spend.
Help me understand a little bit, because I was reading a small article on Vercel website about WASM and edge computing or edge functions and whatnot. What's the added value of having code run at the edge? And give me some use cases for that, because I want to understand what are some of the applications that could be deployed to the edge. And because I'm also a back-end person, in my opinion, always there's the business logic that needs to run in the back end somewhere. Latency is a concern. The proximity of where the front end runs to my back end is also something that we always need to think about, especially when dealing with problems at scale and cost optimization and all of that stuff, right?
Yeah, no, you're 100% right. So we introduced our edge functions, and they run in the data center closest to the user. And you hear that and you're like, great, solves all my problems. Now my users don't have to backhaul all the way to I-81 or US East 1, however you talk about it. Like the center of the universe for the internet is Ashburn, Virginia, like right outside of Dulles Airport. And that's cool. But like, if you've got users in Tokyo, if you've got users in London, like, man, the speed of light isn't so fast that their requests from their browser going to Virginia, that adds up. And so, I heard about edge computing, and I'm like, great, this solves all our problems. We'll just put computing in in every region, so that a user in Tokyo goes and hits a compute endpoint in Tokyo, and boom, everything's solved. But no, as you point out, like it's actually a little bit trickier than that, and so you need to be a little bit more thoughtful about what's happening and what you're doing, because if your database lives in Ashburn, Virginia, and your compute lives in Tokyo, then you're going back and forth. If you do one query, it's fine. If you do 10 queries, that all of a sudden it would have been better to just route the user to I-81 to begin with. So you're absolutely right that there's a lot of nuance here. And actually that's why we added regional edge functions. Edge functions, can operate in any of our regions. We've got computing there to handle them. And it's great for something that needs to make a thoughtful decision, but doesn't actually need a backend data source. Let me give you a concrete example. So our middleware product will operate on the edge. It'll run some compute in the closest region to the user and do it like in front of your requests. So let's say a request comes in for your homepage. Edge middleware can run right there. And it'll run in like this super lightweight V8 isolate. So it's like the best server side latency that really you can get, no real cold starts to speak of, super duper quick to execute. And then it can just like look at the geo IP, for example, and say, oh, you're coming from Berlin. I want to give you my German homepage. You're coming from Amsterdam. I'll give you a homepage that's tailored for the Dutch audience. And so you can make like, it's so middleware, for example, is perfect for simple decisions that don't need a database. Now, how many things don't really need a data source? Well, some, like I think that's a good example, the routing, for example. But then what's cool is that we can actually start bringing more data to the edge as well. So we've got some databases are doing multi-region where you can have a read region close to the user. So that helps. So you can push both the data and the compute out to the edge. One novel thing that we've actually done is called edge config. Instead of pushing it into the region, we push it as close to the function as you can get. So when you're running an edge function, like that data has, millisecond latency to read. And that's perfect for things like A/B testing, feature flags, that sort of stuff, where you really want to be able to go to a dynamic data source, but you don't want to have to backhaul all the way to Ashburn, Virginia. You want that data just as close to the function as you can get it. And so that's super exciting. So I think we'll see more of that. But in the meantime, we've also given you the ability to run your edge functions. So like the lightweight part, the V8 isolate, super fast cold starts in a particular region. So like it's kind of the best of both worlds. So you can say, well, this edge function always runs in I81 or US East 1, however you want to think about that. But like it's super lightweight as opposed to a serverless function, which is good for heavy compute, but has cold starts. So, and again, like our goal is to make you think about these things less. Like, we want to handle the infrastructure for you. We'll just let the framework, we'll let you write the code. The framework will actually, new up the infrastructure for you. And so like, the next iteration needs to simplify this as well. Like you shouldn't have to think about this so much.
Got it. Amazing. Ed, this has been really, really insightful. I really enjoyed our conversation. I want to ask you the very last question for this episode, which is, what is a piece of technology that is exciting you about the future? Like, what are you interested in diving into down the line? What's exciting you right now?
I mean, surely everybody says AI, right? No, but it is AI. Like I spent a lot of years not paying any attention to AI. Like, I had a friend who was like, oh, I'm super pumped about this. Like, I'm going to learn about, all these various models. And I was like, that's cool. But obviously we've reached, I thought it was going to go nowhere, right? Like, I'm like, this is dumb. Obviously we've reached a point where that's not true. I was wrong. I love being wrong about these sorts of bets because it allows me to be very lazy. But of course now I'm behind the curve. And so now I need to go like really invest. I've played around with ChatGPT and I've played around with, Copilot and those sorts of things. And they're phenomenal. But we're super early. And so I think that my former boss, Kath Korovech, she's over at Google, like trying to figure out how we're really going to change the world with this stuff. And I think that's what's really exciting. I'm super glad that Vercel, for example, had, we just announced this AI accelerator program. Like we're just at the very beginning of this. And so I need to go. I've got a lot of learning to do. I've got a lot of catching up to do.
We all do, believe me. And this has been super fantastic. Thank you very much for taking the time. And I hope everybody watching has enjoyed the episode as much as I did. Thank you very much.
Thanks for having me.